All right, so let's go ahead and find the length of this curve. So in order to do it, I need to know what dx dt and dy dt are, because this is my standard formula for this. All right, so dx dt is going to be 2 cosine of 2t, and dy dt is going to be negative sine of t. Yeah, all right. And then so that means that my s is going to be the integral, so my a and b are just here, integral from 0 to 2 pi. Of course, if I did integral 0 to 4 pi, that would essentially mean I'm going around this figure twice, and I would get exactly twice the distance. All right, square root of, and if I went 0 to pi, it would be halfway around, and so forth. So you could sort of simplify things with symmetry, although I don't think it would be terribly helpful here, because we're not going to do these integrals by hand anyway. So I'm going to have 2 cosine of 2t squared plus negative sine of t squared dt. All right, not much we can do to simplify this, but we're going to throw it in the calculator. But before we do that, let's just simplify it at least a little bit. We could probably leave the 2 there, it would be fine, but I'm going to make it 4 anyway. Cosine of 2t squared, and just the negative, since I'm going to square it, it's going to become positive, so plus sine, sine squared t. I guess I could have put the squared over there, but I didn't. All right, and then I just do this in my calculator. I already did it on my calculator. Let's see if I can just find it. I got a bunch of grade calculations for a different class here. I think when I ask this calculator to do things like divide by 40 a bunch of times, that it feels insulted by having to do such easy problems. Yeah, here we go. There's that integral, same integral, and it's 9.429. So 9.429, approximately 9.429, to the nearest thousandth. And yeah, there's a nice way that we can sort of look and verify that this answer makes sense. So if you think about this shape, it's going out to 1, right? So it like goes out to 1, and then it goes over to -1. So in a naive sense, we go 1, 2, 3, 4, 5, 6, 7, 8. Right? So if I was just going back and forth, I would go a distance of 8. So the fact that I'm actually going up and down means this is really longer than 1, this is really longer than 1. So what I get should be a little bit more than 8. And that's what I got, a little bit more than 8. So that's how we can sort of get an idea that the answer makes sense for this particular figure. All right. So there's not much else to say about that except that. We'll just do one more problem from the book. I'm going to do page 536. So this is chapter 10. So we're jumping around a lot because your book separates out the parametric curves from the regular curves. Chapter 10, this is page 536. We're going to do number 32. Okay, I haven't looked at this, so hopefully it won't blow up in my face. We got x equals 8t plus 8 to the 3/2 over 12. I'm looking at the time and thinking I might have to continue this next video, but yeah, there's a t there. Okay, and then we have y equals t squared plus t. And we're doing 0 to 2. All right, so I'm just really curious what this looks like. So t is 0 to 2. So maybe we'll just get that far for now, is look at what it looks like. It's good to make sure you're still familiar with using your calculator. So let's put it on the calculator, even though Desmos would make a nicer drawing. But you don't get to use Desmos on the AP exam. So let's remember that your calculator can do this. So we have to go to mode, and we have to go down from func. We have to go to pair for parametric. And then we can go to our y equals window. We've got stuff in there. That's sort of an old thing that from before. We just, I guess, clear it and clear that. And then let's see if we can put that in there. Well, tell you what, I'll put that in there, and then we'll look at it in the next video so I don't waste your time.